Hey everyone, and thank you for joining OWASP Nova for August 2023. We are with Balaji Vasudevan. He's going to talk about some database activity monitoring. Before we get into that, I wanted to do a couple announcements. Coming up is the OWASP Global AppSec Conference in DC. That's October 30th through November 3rd. So that's going to be a lot of good AppSec content. That's going to have training after the conference. And also in Austin, Texas, there's another OWASP conference coming up, LastCon, which is a favorite of ours, which is just a great smaller conference, but really good content. That's October 24th through the 27th, 2 days of training, 2 days of talks. So if you're interested in more content, definitely check those out. You can find that on the OWASP website. So today's talk, we have Balaji. I'll do a quick intro and hand it off to you to go through the content. So Balaji is a cybersecurity architect with over 13 years of experience in a lot of different areas: data security management, cloud security architecture, ITIL, project management. And he works with a lot of different clients focusing on data protection and privacy implementations. So I'll hand it off to you.
Sure. Thank you. Thanks a lot for the intro, Mike. So good evening all. So thanks to you all for giving me this opportunity. So this session is basically to walk you guys through database activity monitoring. So I hope Mike covered my part. So thank you so much for the intro. So basically what we are trying to do here is I will do my best to help you guys understand what it is about database activity monitoring, where it is located. So we'll try to see what is native auditing tools that we have currently, and what actually is the need that makes data activity monitoring solution a mandate nowadays for all the organizations. And once that is done, we'll try to walk you through the DAM architecture. So that's going to cover your on-prem IaaS and as well as the platform as service model. So how the architecture is different, how it is going to work for the organization. And after that, I will give you some cheats on how DAM solution work for organization, and how you can select the product, how the vendors are going to play with you. So how you can select the best product for the organization or your clients, or if you are yourself an organization, maybe this can help you decide what are all the checkpoints that you need to make sure you need to follow so that you select the right vendor. And then we'll implement how we are going to implement the DAM solution. This is going to be basically I'm going to give you a list of checklist which needs to be followed, and which are like guidelines that can help you when you are going for the implementation. And then the last thing is the continuous life cycle. Once you have the DAM solution implemented for an organization, so how is the continuous life cycle going to be with the day-to-day activities, and how it is going to happen? So maybe at the end of this slides, maybe I hope you guys should understand what it is DAM, and if at all you or your friends or colleagues are trying to solve a solution for their organization or for their clients, maybe you should be able to help them. So, okay, with no further delay, moving on to the first slide. So what it is about native database auditing tools. So we all know that DAM is a database activity monitoring. There are lots of products available in the market, but there is also, we all know that there is a native database auditing tools, let's say an Oracle or a DB2, they come inside with themselves with an auditing tools and their functionalities. So this is more like inbuilt tool. So when a database operates, these auditing policies are going to work within, and they try to ingest the logs into SIEM, where you find what are the actual breaches. And why the clients actually choose to go for native auditing is basically they are worried about their cost of bringing a new server just to monitor their existing database server, and the existing database server already has a component that has a capacity to do the auditing stuff in the database. And so that's natural, right, with the customer. But with the growing security demand, if we analyze, we'll find that native auditing might not be even an optimal solution, or not even an adequate solution for what is the demand from controls and complaints from and then with the day-to-day vulnerabilities, threats that are arising every day. So this is what, so I will try to walk you guys through what are all the issues the customer might face if they are selecting a native database auditing tool. The first thing is performance. So you can see that around 20% drop in your existing performance. Let's say you have a database server with like 100 gigs. So there's going to be a 20% dip from your existing performance. So for sure, because the auditing component is going to run within your database server, so that's natural that it's going to consume your CPU, memory, everything. So for sure, there's going to be a performance degrade. And then the licensing cost. Not all the databases are offering these auditing service free of cost. So you need to pay an additional licensing cost. And the third one, due to this decrease in performance, you'll be forced to upgrade your hardware and storage, because it's like dual. So you are going to have 100 set of transaction. There's going to be 100 set of entry in the log. So it's like your storage and hardware needs to be updated. And the most important thing is the labor. Not all the configurations are going to look same. So because let's say you have an Oracle DB2 Teradata system, and you are trying to activate this native database auditing tools, and probably you need a DBA for each of these flavors who has a knowledge on how to activate these native database auditing tools. So which cost to the labor. And then the separation of duties. Let's say a DBA, he will have access to the audit logs, which is generated within the DB server. So the separation of duties compromised there. And the last thing that would be compromised is the data protection, because you see the sensitive data or the transaction. Let's say I'm trying to do a select on a sensitive table like an SSN1, and what it is going to actually happen is I will be having a logging database within the same server that is going to put the same logs in that logging server as well. So which means my database logs, which is super sensitive, is going to be the information, sensitive information is going to be stored in within the same server in a log file, and they are not so secured as compared to a DAM tool. So these are the primary concerns. So a database monitoring, activity monitoring product is something that is able to actually address all these concerns, and then that would be able to help you guys to address all these issues, and we'll be able to achieve a cost effective as well as the best tool to achieve all your compliances in an automated fashion. So I hope that helps. So now moving on with the database activity monitoring. So as you guys might understand, so database activity monitoring, it is actually designed to safeguard your critical data. So you can have any kind of databases. So what the DAM tool is going to do is actually that it is just going to be the same tool that would be able to monitor all the databases for you. So the critical data can be in whatever flavor of databases you have, and this DAM is going to be able to monitor them. And it's a comprehensive data protection platforms to enable security teams automatically analyze what's happening in the sensitive data environment. So all the activity is going to be real time. So let's say there are millions of transactions happening in a database. All these million transactions are going to pass through the policies, security compliance policies, and even a single breach would be monitored and reported immediately. And we can even block the session. So I will try to walk you guys through when we talk more about the architecture side. And protect sensitive data from internal, external threats. Yeah, that's what the tool is designed for. So any internal or external threats that's arising should be able to be properly handled with the policies like blocking, alerting, notification, and then the next thing is the data classification and vulnerability data management. It is not that I need the DAM to monitor all my databases. Let's say I have a databases that all I use is to just record session. That's not going to be any sensitive. So I need to know what database has before I can actually decide what kind of monitoring that I wanted to impose on. So the DAM tool will have a data classification module that will help you to classify what kind of sensitive data that is stored within the database. Based on that, you can enforce the policies. And then a vulnerability management component that's going to address all the CVEs, whatever emerging threats within the database environment. So the vulnerability management is going to help you guys to address those issues and find how vulnerable. Let's say there is a CVE vulnerability that's happening this evening. So next day morning, you wanted to know what is the impact that it has created on your database system. So all that you need to do on the morning is to view your vulnerability management report from your DAM tool. That's going to say what are all the vulnerabilities that exist. So it's an automated way, but all these things. So the immediate question would happen is how would they know what is the vulnerability? Because just now the Oracle or the DB2 identified it's a bug or a gap within their system. How would the DAM tool know? So DAM tools in this market, so they work closely with all the databases. So as soon as something is arranged or something is emerged, they would be able to immediately provide a patch within a 24 hours timeline, which would be automatically pushed, and your tool should be able to tell you the impact that it has created on your system with immediate effect. And last but not the least, compliance controls. We all have audits, quarterly, monthly, weekly, yearly, all these audits with all big fours. So all once you have this tool set up in a proper way, so all that you need to do, you need not worry much. So all that you need to do when they come is to point to these tools, so they should be able to pull whatever information they want. So they should be able to automate all the complaints control. So these are the basic features of a DAM tool. Basically what happens is the native tool can also achieve this, but not all these functionalities. So they don't have a process to have the data classification, vulnerability, priority user monitoring, or automating complaints controls. So these are all coming as a package. All you need is a single tool. I'm not going to emphasize, or I'm not going to talk about any particular tool. So from a database architect, database security architect, I'm going to tell you how these products are designed in the market and how they are actually achieving this control. And if at all you or your friends or your colleagues are in a need to select one tool, so maybe this should be able to help you guys. And moving on with the DAM architecture. Yeah, here we go. So we all know that this is how the data-based application, it's a very much common architecture diagram that everyone should know. It is just where this DAM tool is getting positioned. So if you see here, the application is here, the database is here, there are clients who are trying to talk to this application, and application is trying to talk to the database. So database activity monitoring is something that is going to position itself just before a layer before the database. So it's going to audit each and every single transaction, and it decide what is the legitimate traffic that I'm allowed to send it or pass through it, what are something that I need to block. All these decisions are made by this DAM tool. Let me give you an common scenario that you guys might have experienced. So most of you might have within your organization might have requested for a database access and try to connect to this database or your database. You might have got your access approved, but still you might have experienced a latency, or there is a connection issue. Your connection is getting terminated on a frequent basis. So you might be trying to complain about the access not being provisioned. The database, the DBA is going to review and say, hey, your ID is already present and you're all good, but somehow you are not able to access the database. Possibly your organization is having a DAM client installed, so which is trying to monitor everything in the background, and then it's going to say if you are not authorized within the DAM tool, it's not going to allow you to pass your connection to go through the database. So all that it will do is to terminate your connection. You will not even be able to access. So next time when you have an experience like this, just make sure that you check whether the DAM tool is actually working within your organization. So yeah, so this is the high level overview of architecture. Now I will try to walk you how this tool works, how we have designed the solutions around the infrastructure as service on-prem, and how now with the emerging platform as service, which all the organization are moving towards, how this tool is going to work. So here we go. So this is the on-prem or the infrastructure as service model. So basically a DAM server has an agent installed. So we will be able to perform agent and agentless functions. So I'll just emphasize on that a little bit late. So let's say this is an organization that is having its data center in United States and Europe, and they are having several server with multiple databases. So you see here, so we have a server one with Oracle, server two with SQL Server Sybase, and Europe is having Teradata, Netezza, Mongo, pretty much all the flavors of databases. So these can be on-prem or in the infrastructure as service. It can be an EC2 kind of system, and they are all like positioned within a server. How the DAM tool is going to work is, so the first thing is I need to have a DAM server with all the policy installed. So most of the DAM server comes with an inbuilt database for storing all the configuration of policies, whatever I need to monitor, and then the database is going to store all the audit logs as well. So in that way, the performance of your database server is not compromised at any point of time. So it's everything is going to be silent at the database side. All these traffic, all these decisions are made by this DAM server that's residing here. And one more thing is, once you have this server ready, we install a component called an agent. Different vendors, when you pass through, or if you have experience, they might name it as a different. Some will call it as an agent, some will call it as an inspector, some with etc., etc., etc. But remember, all these are same. So they are like a component of software. All that software is going to do, they are going to, as I stated before, they are positioned somewhere before the database. So they are going to capture all the traffic, network traffic, and what they are going to send is those logs will be sent to the DAM server, and they are going to act like a firewall here. And what the DAM server is going to have is the policies. So the policy is going to say what are the statements, or who is this. So let's say if Balaji is supposed to is just having a select access to a sensitive table, I'm trying to execute an update. The policy is going to have that covered. And what the DAM server is going to do is it's going to validate the transaction's legitimacy, and based on whether it is valid or invalid, it's going to send back a response to the agent whether to allow me or to block my connection. And not just that, every single transaction logs that's happening. Let's say I have a trillion transaction that's happening. Yes, all the trillion transactions are going to be transferred to this DAM server, and DAM server is going to validate the policy whichever is legitimate, and those legitimate traffic alone would be put inside the database. Let's say if something is an ignore traffic, let's say I have an application ID that is supposed to execute the select, and these are the IPs that is found that it is supposed to come through. Those are not of our concern unless or until there is an anomaly, or let's say application is trying to executing 500 SQLs per day, suddenly it's executing 5,000 or 50,000. So unless or until there is an anomaly, I'm not concerned about that. So whatever that is going to match my policy, and those transactions are going to be put inside this DAM server. And this DAM server will have a component that actually reads through this network traffic and actually tries to insert it. The network traffic are actually going to be raw data. So the DAM server actually reads through the traffic from which client IP this is coming from which zone it is coming from, which data center, what database server it is hitting. Every single information is going to be here. And once it has this information read, it is going to pass through the list of policy that the organization has set up within this DAM server. And whether based on an allow or a deny action, it's going to send back a response to the DAM server. But at the end of the day, this DAM server is going to hold all the information with respect to the transaction that's happening within the database. And when I talked about the native auditing, I told, right, so each database server needs a separate DBA. Let's say a Teradata native tool auditing and Oracle might not be the same. You need to have the different DBAs to work on those. But when you come with the DAM server, it's the single agent. If you see, just by server specific, as soon as it is installed, since the transaction is happening at the network layer, so I'm not going to care whatever database that's going to reside within the server and whatever operating system that you're going to use. So all I do is to take back that network traffic, send it back, and this DAM server has all the intelligence to capture and find out what database it is, from where it is coming, everything, and send back a response. So I need not worry about the databases. All I need is to install the agent on the server. And as soon as the agent is installed and the policy is enforced, yeah, you're good. Each and every single transaction is going to be monitored. So these are some of the things that it tries to cover. The first thing, as I told, is data classification. So this is agent based. So you don't need an agent to run. So what typically the DAM server that's available in the market, they do is they try to have an ID within this DB, and they try to go inside the database and try to do the scan for data classification and vulnerability, whatever that exists, and then try to generate a report. So the data classification and vulnerability management can happen agentless. And the rest of the thing for regulation policies, as I say, block unauthorized connection. These are all something that I need to address real time. So let's say this server is going to send a request and response. So everything should be real time, right? So let's say I wanted to block unauthorized connection. So let's say today 1,000 traffic is coming. So I need to send 1,000 traffic here, out of which 20 are invalid. I need to send it in a real time basis. So these are all going to need your agent installed. So these are some of the basic policies I just mentioned: blocking unauthorized connection, fail logins, sensitive table monitoring, privileged user monitoring. These are all should be pretty much right before an organization faces a bigger problem. So let's say someone who is unauthorized to touch a sensitive table, or a privileged user is trying to do some anomalies. So these are all something we need to address as soon as it is happening, and that's where the agent plays a critical role in reporting all these activities in a real-time basis. And then once all these information are available, I can generate my own custom reports and alerting either to Splunk, or I can just send those reporting to S3 bucket on a daily basis. So these are all the reports for this particular server, server 1, server 2, server 3. I should have all this detail. So when the auditors come, all I need to point them is to these reports. So whatever data they want should be available in those buckets, and the alerting ticket should be able to help them. These are all the incidents or security alerts that arise for my organization. Last thing is anomalies. So the anomaly detection, as I told previously, it is going to find some uncommon activities within your databases. Let's say, as I told, there are 500 transactions supposed to happen, but 5,000 or 50,000, or this user never logged in, but he's trying to log in. So those kind of anomaly detection happens from this DAM server, and those are also getting audited. And this is about the on-prem and IaaS model. And moving on with the PaaS model. So now that you see, so I have a server here, I have installed an agent, and this agent is actually trying to monitor each and every single transaction that's happening. But when I go to platform as a service, I'm not going to have any server, right? So all I have is the database. I just try to procure a database. It can be Oracle, Aurora, Postgres, whatever I want. I'm just going to procure that database alone. So how the architecture is going to be different there? So you see, there is no server. And let's say an organization wishes that they wanted to go everything serverless, including my DAM solution should be serverless. Here is one architecture diagram. You see, these are all, these are all the RDS. RDS are typically serverless environment. So it can be whatever database, it can be Oracle, Aurora, SQL servers, and they are all RDS. They don't have a server. And then my DAM server, instead of this physical server having an inbuilt database, what I can do is to put this DAM. So these DAM come as a within Dockers and Kubernetes. So you can just deploy them with ECS, Fargate kind of thing. And then these are going to be serverless. And the database, whatever I mentioned, that reside within the DAM server can also be moved out to an RDS, DAM database RDS. So that's going to hold all the audit data and configuration. So instead of agents that sending the databases, so we have an option to trail the DB audit logs from the RDS to the DAM server, and this DAM server can take an action and report on those logs or alert or block those transactions. And these are all something that this DAM server sitting here can actually action upon. And now, so I just try to explain one case study for AWS, because that's where most of the time I work. So I have taken the use case of an Aurora Postgres. So if you see here, it has a master and a reader instance. And it's typically going to be how these data are going to flow is basically using the Amazon Kinesis data stream. So what I'm going to do is to trail all these audit logs, because I have clients who have trillions of transactions happening. So I need to handle all those things. It can be trillion or billion or even 100, but not even one single transaction is supposed to be lost just because I don't have the proper infrastructure. So what we'll do is we'll try to procure Kinesis data stream, so which is good at streaming data. So what I'm going to do is on a real-time basis, whatever transaction audit logs is going to flow here, I'm going to trail that to this Kinesis data stream. Most of the organization would have this Firehose part where they put all those trail logs into S3 bucket. And from these S3 bucket, they try to read through Splunk or kind, so which typically looks like a native auditing tool. But where our tool comes is with this data stream, I can ask, we can deploy, as we said. So this product, whatever you see here, right? This part actually will be here. This is the partner data security app. So this is going to reside here, and it can decide on a near real-time basis whether should I allow this transaction or to deny this transaction. What it is actioning? Should I alert for this transaction? Should I report it? And is there an anomaly cost? Every single transaction from the Kinesis data stream would be sent to this security apps, and then I'm going to notify and take the action accordingly. So yeah, so to access those databases, the secret key would be shared. So that's where this part comes in. Maybe I can just handle all your questions at the end. So maybe, yeah. So now we saw about how the on-prem infrastructure as a service works, how the PaaS model works, more specific use case for a PaaS, and now how my enterprise architecture would look. So can you just imagine? So this is a US data center. Let's assume it to be a on-prem, and UK, it can be a IaaS cloud infrastructure in EC2. So this is going to be there, and this is going to be platform as a service. So all these infrastructure are having my DAM tool installed, and the same policy irrespective of it's going to be within server or it's a serverless. All those defined compliance policies are going to be running. And the one question we might ask is, see, this is just for a diagrammatic representation. I just represented one or two DAM collectors. But if you take on a real-time organization, let's say they have 5,000 DB servers, you might end up with 1,000, with the 5,000, you might end up like 200 or 300 DAM collector servers. So these are called as collector servers because all they do is to collect the data and then analyze it and take the decisions. So let's say you have an organization like 5,000 databases having 500 DAM collectors. And how would I be able to monitor them? So let's say I have an auditor who wanted to select 100 servers in random, and then I wanted to analyze the data in 100 servers. Should I log into 100 database DAM servers? The question, the answer to that is the aggregators and the central manager components. So all the products in the market, they come with these aggregators. They might use different kinds of aggregator or a third party, but what the aggregators actually do is they have a link to these collectors that can be positioned either in a data center or in a cloud or an ECS. And what they actually try to do is to interact with them. Let's say an auditor comes there, out of 5,000, I have selected, sampled 50 database, and we wanted to know what is the status of the monitoring, what are the policies that's installed. So all I will try to grab them is a role within this aggregators and central manager. They would be able to log in within these aggregators, and they should be able to do the sampling. I mean, they should be able to do audit on the samples that they have selected for these data center and PaaS. So in that way, there is a link so that it's going to be a one-point connection where you can view all the logs. Let's say from an administrator standpoint, let's say an agent on this database server is having some issues and that's not reporting the data properly. So probably a security admin will alone need access to all those 500 servers to point if at all there is some issues, they can log in and try to fix it there. So this is all about the enterprise architecture. So now that we have covered the architecture part, now selection of DAM product. So this is going to be a very tough phase. So I try to give you guys an example of a situation that you might land up. Let's say your client can be organization A, B, or C, whatever they want, and most of the products that's available in the market is going to fall either in product A or B, but I'm not going to name them. So maybe if you have a chance to work on those solutions, so you should be able to know what are the products that should suit either the product A or B. So okay, we'll take the scenario of organization A. So they are a mid-sized company, and they just have 50 DBs of Oracle flavor, and all of them are on-prem or IaaS. So I have a server in place. So all that they are looking for is agent-based solution. And the second thing what they are selling is Enforced DAM solution should not affect DBU, CPU, or memory. We have seen in native auditing tools, right? So because of usage of native auditing tools, because those tools have the intelligence, or they are trying to utilize the CPU to make sure the transaction and analyze the policies, they can impact your DB performance. So this client is saying that I don't wanted the installed DAM product to affect my DB performance. Okay. And third thing they are saying is all 50 DBs they are having a heavy lifter. So they are going to process millions of transactions per day, which means that the DAM tool that I'm going to propose should be able to handle all these million transactions. They are going to, all these million transactions are going to be audited, and they need to take an action accordingly. And then fourth one they are emphasizing is the DB can't get additional CPU cores by memory as needed. So you might think why they are talking about the databases cores and memory. Maybe you will know once I talk about the product. So because the licensing model, it's not always bring your own licensing model. So some products which are even top in the market, they have some different licensing model. Maybe we'll discuss about that when we discuss more about the product solution. So this is going to get additional memory. So every year there is going to be a change. Let's say this where I have some 2 cores, next year it's going to be 4 core based on the expansion of my business, and it's like growing for them. And they are looking for a budget friendly, naturally the mid-sized company, they are going to look for a budget friendly DAM solution. So this is all about organization A. And now moving on to organization B. So this is going to be a big company with 5,000 databases, and they are going to have different flavors. It's not just Oracle. They are going to have mixture of Oracle, SQL, Sybase, Red Hat, Redshift, everything put together in on-prem, IaaS, and platform as a service model. And most of the DBs are having sufficient core memory that have room to handle additional need for DAM agent. So the customer might not say this explicitly, but if you are a data security architect, you will be able to understand this based on the based on their structure. So how much database is actually handling, how much it is actually free. So from my experience, I have seen several customers who have over resourced or overpowered their DB server, which they don't actually need, but just to be on the safer side, that such that they don't mess out with the, or there is some outage cost. This is also possible due to poor capacity planning. So these are all something that can come to these examples for these points. And then the third one is the DBs are occupied during specified time of a year. So for organization A, there are 50 DBs, but all 50 are busy throughout the year. But this is not the case. Maybe he might be a retail client who is busy during Thanksgiving and Christmas. So these are all possible scenarios. It's not like every day he gets all those transactions. On a peak time, he gets more business. And that's where the DBs are going to be more occupied. And the fourth one that they are emphasizing is the organization don't have plan to add additional CPU because they have already overpowered their servers. That's natural that they are not going, they might have, right? So as soon as you are going to overpower your servers, at some point of time when you analyze, so you're going to find that they are already overpowered. So instead of reducing, we'll stay with the same capacity. And then the last one is budget is not an issue for them because they have 5,000, they are a big four, they are a big company, and they have different flavors. So budget is not an issue for them. Now let us come to products. So these two companies are trying to find a DAM solution for their organization. So we have first the product A. So they are an emerging DAM product who support Oracle, SQL Server, and Sybase alone. But still they are covering the Oracle ones. But these might not be a best fit for organization B because they use different flavors. And the DAM architecture works such that agent doesn't have any intelligence. All it does is to send network packets to DAM server, and it can take allow or deny action based on response received. So this is typical architecture, whatever we discuss. All that it does is it's going to send the server, and then the DAM server is going to send back the response. So in that way, I'm not going to cause any latency to your CPUs or your database servers. And third one is agent sends logs to DAM server every 1/10 of a second. So I need this performance to handle million transactions per day. Let's say there are millions of transactions that's happening. I should have a robust tool that is able to respond to all million transactions within the stipulated time. If not, there's going to be a performance lag. Someone might, let's say you are trying to purchase something, and this damn server is trying to evaluate something, and you are going to be in a latency. Why the things are not loading for me? You're going to get frustrated, right? At the end of the day, the end user. So 1/10 of a second is pretty much good. So you are going to receive the response very quick. And then the licensing is based on DAM servers purchased. So you will know that when I talk about product B, so the DAM, because they don't have additional CPU cores. So this is all, let's say for 50 dBs, they are going to purchase 5 DAM servers. All I'm going to pay is for these 5 DAM servers alone, nothing more than that. And they offer a licensing discount of 40% for if you're going to, this is something common, but I don't want to emphasize about these kinds of things here. But these are all something as a data solution architect, even though you are not a part of sales or marketing, but you might land up, which might be best suit for proposing, because you need to propose a holistic solution when you go back to client. And let's analyze what product B gives here. So they are the leading solution in the DAM market and supports all DB, and which suits product organization B. And any new version of database will get its support within a week. Let's say there is a new release in Oracle or a Redshift, so they are going to produce the support within a week. And DAM architecture works such that agent does have intelligence to analyze traffic. And so when you go with the product, they will say that the agent should have, there are some products, they will say that their agent have the capacity to analyze and take a decision. So in that way, I'm not going to send the response to the DAM collector. What the DAM can do is I can have a part of my policy installed here, like the blocking policies. So the DAM agent will have the intelligence to take a decision whether to allow or deny a transaction instead of sending the transaction there and getting back. But if my DAM server is going to, agent is going to do that, I'm going to take your database performance. That's where the key comes in here, because they are overpowered already. I believe this would be the best solution for them. And the agent sending logs for the DAM server can be adjusted to 1/10 or every 30 seconds. This is like 1/10 every time. But where this product can suit is, see, they have, this not like they have what to say, transaction happening all around the year. So they just have a specific period. So not always they wanted the 1/10 of the second to be followed, because for an agent to take a decision within 1/10 of a second, it's going to consume more of your CPU and memory. So it's not always the case. So, and the last thing is licensing is fixed. So they don't have, and it is based on number of DB server cores. So you might land up with the DAM tools. They are proposing a license based on how much DB server cores you have. And the licensing model works in based on number of DB server cores. So this is most common licensing format when you go to DAM solutions. But how this solution can vary is, see, if I'm going to give this solution to organizations, say, let's say licensing based on number of cores, and every year they are going to, organization A is going to update their memory and CPU usage based on their budget. So every year they might end up paying more. So this might not be a best solution, but these are already over provisioned. So all they are going to provide pay is for whatever infrastructure they have. So that's where the solution can be a good fit for organization B. And product A is just going to be working on based on the DAM server license that you have purchased. So for me, it is pretty much stable, right? I just have 50 database 5. So it's like a very fixed budget that I can use with this product A. So that's how, as a data security architect, you'll be in a position to navigate around the products in the market. Not always the market leaders are the best fit for your clients. Sometimes there might be even a better product, which is better in performance, better in cost, better in all aspects, that can be suitable for your clients or customers. So yeah, pretty much that's what I wanted to cover as a part of this slide. And now moving on with the implementation part. So the very important part. So once you have selected your product A or B or C, whatever that you wanted to implement. So now that you are going, the architecture is pretty much the same for all these. As I told, they might name this component different way, but most of the architecture works in the same way. And when you go to the capacity planning, so there are something that you need to make sure. Use collectors that is more near to the DB host for monitoring the DB. Why this is let's say I can, the DAM server, what to say, the vendors are going to say, you know something, my product has an intelligence such that an on-prem DAM server can monitor a cloud database. Let's say this DAM collector would be able to monitor a cloud one, and the cloud server can monitor the US data centers one. So both of the thing, both ways possible. They are going to emphasis on that, but the catch point there is that there might be a latency. Let's say when you move from your database server from one zone to another zone, there might be a latency. So let's say a DAM server, from when you analyze a performance, let's say I am trying to monitor a DB server in a UK data center from US, and there might be a network latency because of the hops that's happening. And when you try to complain this to the vendor, they are going to say, see, I got these evidences, my DAM server has processed already correctly. The problem is that you crossed map in this all because of your network bandwidth that you have, which is slow, which has caused this latency. So they might not come back when you are when they're selling the product, but this is something you need to make sure whenever you are trying to purchase. So make sure the DAM server is very much close. You are in US East 1, make sure you are in US East 1, the DAM servers, they are close to your database. And then the ingress and the egress. Let's say if you have decided to use your on-prem for monitoring both on-prem and cloud, there is an ingress and egress charges, right? So let's say, as I told, the agent is going to send all the transaction to this DAM collector. Let's say this collector, this one US is in cloud and UK is in on-prem. Let's say I'm going to map this server 3 from here to here. So all these transactions are going here, and let's say this Oracle is a very heavy lifter that's trending trillions of transactions, let's say gigabytes of data every 1 hour. And what would happen is whenever there is an ingress and egress from on-prem to cloud, you might end up paying charges for those data being transferred. This is very important point to note, because I have seen customers who have paid a very big amount, more than their licensing cost, because they didn't plan this part correctly. And the third one is synchronous blocking node. So as I told you, whenever you are using a blocking mode, let's say I wanted to block some unauthorized connections, I need to make sure the server, the best thing is to have it very much near to your DB server. So even if it is within the same VLAN, that would be even more great. So within your DB server. So in that way, the latency or the response the agent takes to send it from the DB server to server, DAM server, and getting a response and taking an action, all those can be reduced. And the fourth thing is, try to find how much network bandwidth is happening. Let's say your database is not heavy lifter. So it is not like 1:1. Each database server should have a DAM server. No, if you see here, I had 2 databases here mapped to the same DAM collector, and 4 here mapped to the same DAM collector. So it is based on your network latency. You can even map 20, 40, whatever you want. So you need to analyze how much traffic is happening in your DB server, and then plan the capacity of DAM accordingly. So make sure the required DAM ports are open. So once you install all your products, then there is going to be a shout, oh, I'm not able to connect to the server. The vulnerability management component is not able to scan. Possibly each of these DAM product comes with their own ports. So you need to make sure all the required ports are open at the network layer, so that that transactions are not getting blocked. So this is something that's important. And then a proper backup needs to be planned for your DAM server. Just because this is audited, see, your DAM server is going to hold all these database server data. So which means that each inbuilt database is also going to be filled at a rapid rate based on the amount of transaction that's happening. So I need to have a proper backup so that I can plan the archiving, purging of these logs within the DAM server. So in that way, I'm not going to have a DAM server shutdown because it's out of space on one day or something. And the last thing is DAM infrastructure. As I told, if you have a 5000 DB server and there are 500 or 50 or 100 DAM servers, so you need a proper patching of these DAM servers, because they are also tools, right? So they need to be patched, backup should be taken, policy configuration, all these needs to be taken care. So this is something that you need to be cautious while implementing the DAM solution. And now comes the important part. So once you have your DAM tool ready, your risk and compliance team is going to say, see, these are all something that I wanted to monitor. So the first policy is going to be 3 file logins within 2 minutes. I want that to be alerted. Okay, that's possible. Block unauthorized access to sensitive table. They are going to say the sensitive tables within the databases should be blocked. So which means that it's a two-way communication. I need to act on this one. Third one is the system default accounts like system rman should be logged, and unlocking should create an alert. These are all highly privileged IDs for Oracle, and similarly we have several for SAP systems, your what to say, Redshift, everywhere. So as a part of compliance, these privileged IDs should be locked, and unlocking should be creating an alert. And all privileged user activity should be logged. Let's say for some reason I'm going to unlock and do some activities, whatever activities I'm going to do with that should be audited, should be logged and audited. And then the fifth one, non-application ID cannot access an application database, and connection should be blocked. Let's say I'm a DB, I'm trying to do a select on an application table. That's pretty much possible. So such action should be blocked with immediate effect. So these are all something that compliance team. And as a data solution architect, you need to know to position these rules within your DAM product. You can do that within the same order. They are going to work. But there is a better way of doing it is to find out which are all the two-way communication. So you see anything that's going to have a blocking policy, because blocking policies typically you are going to send a whatever the agent. Let me go. So for blocking policy, the agent is going to find the transaction, send it to the collector, and and the collector is going to analyze, send back the verdict, and then the DAM agent is going to take a decision whether to allow or deny. So this is having some latency. And how most of the DAM product works is they work like, let's say I have 1 million transaction. All these million transaction are going to go in a top-down manner for these policies. So they are going to evaluate it first with this, second with this, third with this, fourth with this, fifth with this. So that's how it's going to happen. So let's say I have application ID, and that is something that is commonly happening. Even though it is not going to fall as a part of first 4 rules, it is going to pass through them and then come here. And there are chances that the network latency, there are some cases I have seen where there is a latency. The application team might be shouting that no, the performance is affected. I have a best DB server. They will try to improve the performance of the DB server, but it is actually the positioning of the DAM policies that is causing those latency. But most of the time they might think that it is just the agent sitting and there is no performance issue with the agent. We are good. But whenever you are running, and I know that I hope that there are DBAs here as well. So let's say whenever you have a very good system at the database, which is good in performance, but still you are experiencing some latency in the traffic and your connection is getting blocked or getting delayed, possible reason is that DAM policies are not configured correctly. So this is the right way. I'm going to pick up the 2 blocking policies, the second and the fifth one, and I'm going to position them first. So blocking policies are going to be evaluated first. So in that way, I take the action immediately on them, and then followed by which I can do the fail logging. These are all something to be alerted, right? So it is not a two-way. As soon as I get the logs, I'm going to alert on them. And system default, as soon as I get, I'm going to alert on them. And privileged IC, as soon as I get, I'm going to audit, I'm going to log them. So these are all like not like two-way. So these are the first 2 are the two-way transactions. So you need to position the policies, the blocking policies first. So in that way, you are able to handle the traffic in a in the best way. So these are all some tips that I'm trying to give you guys. So I know data security architects are going to be there in this team or your friends. So if at all they are having any issues, maybe you can suggest, or maybe you yourself. There are definitely chances, because with this are a lot of organization moving into DAM culture, you should be able to see these issues. And don't worry about this flowchart. So I just designed how you can do an end-to-end zero-touch automation. So this is how I do for most of my customers. So within my organization, so how we do is, let's say you have so I just created this use case. So how you can better plan. So you have seen, there are going to be, you need to set up this system, install agent. Let's say I have 100 servers coming daily. I need to install agent on 100 servers daily. I need to enforce the right policies. So how am I going to do in an automated fashion? There should be some automation way, right? So this is what I shared. So let's say there is a service now. So or can be any ticketing or a resourcing tool that you use whenever there is an onboarding or offboarding request. So what we typically do is we find whether it is a new onboarding or an old decommission. So if it is going to be a new onboarding, what you can do, I'm going to take it, my automation is going to decide whether it is an IaaS or a PaaS. So if it is an on-prem or an IaaS, I need to go for an agent-based approach. And if it is for a platform as a service, I need to go for an audit trail-based approach. So based on this choice, maybe let's for on-prem, what I'm going to do is to do the classification and vulnerability assessment scanning as soon as your database is ready, so that we will be able to show if there are, I'm going to check if there are vulnerabilities, I'm going to let the concerned team, or if there are some automation to fix it, my automation script is going to trigger that automation so that they are fixed. And if not, the vulnerability part will stop here. With respect to activity classification, so based on the classified, let's say I have a sensitive data like SSN, credit cards, passport numbers within my database. So what I'm going to do based on the classification, and if it is yes, so what I'm going to do is to go ahead and install the DAM agent on the DB server and send the logs to the nearest on-prem or the IaaS DAM server. And then based on the classified data, I'm going to enforce compliance policies based on the classification, how sensitive, what are the sensitive tables that I have found, what are the privileged users they exist. I'm going to enforce those policies and then configure those reporting and alerting. These are all can be handled automatically. And we have several APIs with the DAM tools that you can leverage to do all these tasks. And once this is done, it is not going to be one-time activity. What I will do is weekly, it can be daily, weekly. So based on your organization need, you can loop this automation that's going to do for all the existing databases on a weekly basis. Still the classification, still the vulnerability exists. So what is going to be the approach that I'm going to follow? So let's say if there is no sensitive data, I need not monitor the database, right? So why should I monitor which doesn't have anything? So I can take a decision. And if you go to PaaS model, same to what we discussed for on-prem. So instead of this, I'm going to send it to the ECS DAM server. It's going to do the vulnerability and classification. If I'm going to find the vulnerabilities, yes, I'm going to notify the concerned team. If not, stop it here. And I'm going to classify the data. Yes, configure the PaaS DB trial logs to be sent to ECS deployed DAM servers. And then going to enforce the compliance policy, reporting, and then I'm going to loop through this process on a daily basis. Whenever there is a new onboarding, that's going to come here. And once it's an existing onboarding, it's going to loop through here. And let's say my database is done. It's been here for 5 years, and I'm in the process of retiring. So we'll have the offboarding request automation triggered there. What it is going to do is to take a decision, whether it's going to be on-prem or PaaS. So if it is an on-prem, what I'm going to do is to go ahead, uninstall the agent automatically and disable all the reporting within it. And if it is a PaaS, I'm going to go ahead, disable the trailing logs and reports, and then I'm going to stop here. So this is how an end-to-end automation works for DAM. So if you're a data security architect, I believe you should be very much familiar with designing these kinds of solutions. But all this process can be made zero touch, guys. Trust me. So with my experience, yeah, we have done zero touch so that everything is happening in an automated way. So whenever you are provisioning a DB, you can make sure that all these are addressed. So one manual way that you can find is notifying concerned team to fix it. But with my experience, we have automated ways to fix those vulnerability as well. So we have scripts. So that's going to, instead of this one, it can be a Lambda that has a fix for that vulnerability. What your automation can do is to go ahead, touch that one with the APIs, and it's going to fix the vulnerabilities automatically. So if you take for an enterprise-wide organization, so this is how you build an end-to-end life cycle of a DAM solution. All right, time is okay. So we just have 6 more minutes. Okay. Question. So yeah, Mike, I believe I'm done. So maybe if there is any questions, I'm very much happy to answer.
Hey, yeah, thanks. That was a really interesting presentation. Learned quite a bit, and it's an area that I don't know a huge amount about because I don't deal with this area as much. But I had a couple of questions. Where do you think this technology is kind of going? How do you think it's improving over time, and how is it changing with cloud-based workloads?
Yeah, as I told, yeah, that's how with respect to cloud, yeah, now most of the people are going for a platform as a service kind of architecture, as you see. And there are lots of in-house tools that they are trying to leverage, as I showed here. But with my experience, most of the people wanted to go for a platform as a service. That's where they can save cost. At the same time, they need not worry much about the infrastructure. But yes, so the end solution is now moving towards a platform as a service model from on-prem and IaaS. So they are mostly like they are in the retiring phase. So PaaS and SaaS are are like emerging things for this damn solution. Most of the issues or new vulnerabilities or fix or new enhancement is actually happening around this platform as service databases.
Gotcha. Very cool.
Mm-hmm.
Cool. I don't think we had any other questions, but thanks for giving this presentation. It was really interesting and informative.
Mm-hmm. Thank you.
All right. Thanks everyone who joined, and we'll see you next month.